Now we are going to see shortest job first scheduling using non-preemptive version. So shortest job first in the sense here we have to allow the process to be executed in CPU based on their burst time. Burst time in the sense how long it should be in the CPU. So that denotes the burst time. So here I have six process P0, P1, P2, P3, P4, P5, each arriving in different times, and the burst time varies according to their job. So if there is no arrival time, you can take the arrival time as zero. That means everyone comes at the same time. That is at zero. So here we have a different arrival time. No, that means in 0th second P2 is arriving, first second P0 is arriving, second P1, and second P1 and P4 both are arriving at the same time. P3 arrives at 3, P5 arrives at 6th second. You can go with seconds or milliseconds. It depends on the system unit. So here I have the burst time, the way different burst times. So at 0th second, who is arriving? Only P2. So we have to allow P2, as it since it is non-preemptive. Non-preemptive in the sense once a process is getting inside the CPU, it should complete its task. So then only it will leave from the CPU. That means P2 is arriving at 0th second. So we have to allow P2 to be there in the CPU for 2 seconds. So till 2, P2 will be there in the CPU. It can do its work. So it should complete its work and then it can leave. So in the while executing that P2, so in this 2 seconds, be, between this 2 seconds, who is arriving? So we are having P0 will be arriving at first second, no? So if more than one process arrives at same time, so then we have to go with the person, that is the process who is having the shortest job. That means shortest burst time. Based on that, we are allowing the process. So as per that, we are allowing what P0. Then in the third second, who is coming? P4 and P5. Sorry, in the second who is coming? P4 and P5. So among these three process, who is having the shortest job? So we can allow that process accordingly. Like that, we are allowing all the process. So 0 to 2, P0 is having 3 seconds work, so 2 to 5. P4 is having 4 second work, 5 to 9. And P5 is having 2 second work, P1 is having 6 second work. Like that, we are completing all the process. Then coming to the formulation. So here arrival we are calculating the as per the given input data, we are writing the arrival time and burst time. So we are calculating the completion time, turnaround time, melting time, as we have a formula, right? So turnaround time formula is what? Completion time minus arrival time. Completion time here they have given like finish time. Finish time. Finish time is nothing but the last occurrence right side value will be considered as the finishing time. That means when the process is getting completed, when it is leaving from the CPU, that is what the completion time is. So from that formula, we are calculating turnaround time, and the waiting time formula is turnaround time minus burst time. So as per the formula, we are calculating all these three. Then in the shortest job first scheduling, we are having a preemptive version. That means if the process is getting executed, for example here P2 is arriving at 0 second, no? So in the first second who is coming? It's 3, right? I mean the process P0. Suppose instead of 3, consider the P2 is having 3 second work. For example, I'm telling it is having 3 second work when P0 is having 1 second work. In the first second, if P0 is coming, so P0 is having only 1 second work, P2 will be having 2 second work, 2 more second work, right? So who is having the shortest burst time? That means the incoming process. So we have to stop the process P2 and we are allowing P0 to get executed in the CPU. That is called shortest job first scheduling preemptive. It is otherwise called as shortest remaining time first scheduling. So preemption means what? We are stopping one process and we are allowing another process to be executed in the CPU. So based on that, we are for constructing the Gantt chart and the calculations as usual.